Hi there and welcome back to another episode of Engineering Things on this tutorial or introductory tutorial to PySpice. Today we're going to be talking a little bit about using a basic DC sweep and also a custom DC sweep. So we'll start off with what most people will have probably worked with before in Spice programs, and that is just a basic sweep. So that's when we want to sweep a voltage from a starting value, some particular step that's user defined, and then a stop value, and we sweep across those values. So let's head over to some code and consider how we might do that. So we're back here now on Atom, the editor of my choice. You can see this is very similar to what we were working with before. We've got some imports and we're going to start plotting things this time around, so we're going to start using some of this. Don't forget to add import OS, that will become more relevant. Then we set up the ngSpice subprocess so that we can use it with Windows for Subsystem Linux properly. That's all the setup, and we come down here, and the first thing we're going to do, and I've already done this, is write out a very simple circuit. So we're using the same diode as we were in the previous part 3 of the tutorial, and then we're creating a very basic circuit with a diode and a resistor. So I'm going to pull that up on LT-Spice. This is the exact circuit we've just made. So we've got a voltage, a diode, and then so node 1 is the input voltage, node 2 is the output voltage, and then we have a shunt resistor as well. Okay, so we have this working. As we can see. So I can pull in my Windows Subsystem Linux. I can zoom in a little bit, and if we run it, ignore that. What we have is what we're used to. So we have a we print the circuit and then we've run it. So what we actually want to do is we want to add in a couple of printouts so we can actually see the analysis. So first thing we're going to do is print. Let's go node. And then we'll go string, analysis, and we want to look at node 1. And then we want to see the values which have been produced at node 1. So then we'll do numpy.array of analysis node 1. And then we're going to do the same with node 2. So now if we run this, we should find that the name of the node is printed, in this case node 1, because we selected 1. The value, the input value which we've selected currently on our operating point analysis is 10, and then our output value is 9.2. So we've got the circuit working properly, and again, node 1 is the input node, node 2 is the output node. So this is all well and good, but quite a lot of the time doing a simple operating point analysis isn't really particularly useful. So what we want to do is we want to actually do a DC sweep, and then we can see the effect of lots of different voltage values on the circuit we're simulating. So to do that, rather than using the simulator.operating point analysis, what we now want to do is get rid of operating point, and we simply want to do DC. We're now doing a DC simulation. And if we're doing a DC simulation, we need to define which voltage source is being swept. So in this case, the only voltage source we have is V input, and you've got to be very careful at this point because it's case sensitive. So big V, and then it's the name given to it. So in this case, we just write it in directly. So V in input, and we're going to make that equal. And we use a slice, which is a little bit like a range. So we create a slice, And we're going to slice from perhaps 0 volts up to 5 volts, and let's go in steps of 0.1. So now we can run this. So let's go over back to our console. We're running it, and you can see now that we have our node 1 values, inputs, which is 0, 0.1, 0.2, 0.3, 0.4, 0.5, so on up to 5 volts. And then we have our computed output voltages. So that's looking pretty good. However, we want to visualize it. At this point, it's very useful to start trying to visualize our outputs, and then we can compare the graph to LT-Spice. So what we're going to do now is we're going to plot graph. So let's create a figure. Figure equals plot dot figure, and then we want to plot. What do we want to plot? We want to plot the input array, so the inputs, so the input voltages, so the voltages on node 1, and we want to plot that against the voltages of the output at node 2. And then I've written this already, so I'm just going to copy this in. The X label is going to be the input voltage, node 1, and the output is output voltage at node 2. And then because I'm running it on Windows for Sublet System Linux, I haven't actually got the pop-out plotting system working, so we're just going to save it in my local file. So we're saving it as the SimOut PNG DPI 300. So let's now run that. Once again, there we go. We have an output. So this is the PNG that's been plotted, and we can see that we do get this diode sort of characteristic that we'd expect. And if we go over to LT-Spice, we can do similarly. We've got 0 to up to 5, 0.1. So we can run that, and then if we plot the output, we can see it's pretty similar. So it starts curving off at about 0.5 volts. And sure enough, that is indeed what we have here. So it's doing the same thing, which means it's working. So that is how you do a simple DC sweep in PySpice. Okay, so next comes the more complicated thing we're going to talk about, and that is the use of custom DC sweeps. Now, I think it's important for me to define what I mean by a custom DC sweep. So rather than sweeping from a start to stop value with a specific spacing, a specific step size, what I'm talking about now is when we want to sweep a voltage, but we want to use a custom input array. So it's very important to bear in mind. We've selected some custom input voltages, so whatever that may be, maybe 1 volt, 2 volt, 5 volts, 10 volts, minus 1 volts. So we're no longer doing this sweep from start to stop. We're now thinking, oh well, perhaps we want to extend this functionality a little bit and use a custom input array for the voltages. And this normally is not really possible. However, it can be done, and we can do it here using a little hack, which took me a bit of time to figure out, because in my work this was something I wanted to be able to do, to test sort of an input pulses being applied to some device, and we can kind of, there might be other ways to do this, but I think this is a very interesting way of applying it with PySpice. So the little hack that we have to do, the first thing is we have to sort of create an imaginary node. So we have an imaginary voltage, and then we sweep the voltage on that imaginary node in steps of 1. So we go from 1 to whatever, so we sweep it. And this is the important bit. What we then do is we create a B source. So that's a voltage or current source of custom characteristic, and that custom characteristic is a piecewise linear function, and it is a piecewise linear function of the custom input array, and then it uses the input imaginary voltage to index that array. So it sounds a bit convoluted, and there may be other ways to do this, but this is a very I have found so far very useful. So I'm gonna explain it here. So we're gonna go over, and I'm gonna start implementing the code, so you can see how that might work. Okay. Okay, so we're back on our code, and this is what we were working with before. So we're now on part 2 of tutorial 4, and we're going to start doing what I mentioned. So the first things first is we're actually going to get rid of, we're no longer using a normal input. So we're going to call this VI. So it's the imaginary node, so the I imaginary node, and it's an imaginary voltage source, and we're going to call the node img for imaginary. So this voltage source named I is connected from a node called img to ground. That's all it's doing, and it doesn't really matter what the voltage is here because we're going to sweep it. So we now have imaginary. Okay. Next, what we want to do is we want to define this B source. But to define the B source, we're going to first create this input data array. Now, before we can do that, we need to consider the syntax. So first of all, let's just create the B source. So it's circuit.b, just like many of the other components. Let's call it BS for the B source. And then we're going to connect it from node 1 because this is actually our input at this point. And then we'll connect it to circuit ground. And then what we do is we now enter the characteristic. So this now is kind of an equation. So what we're saying is the voltage being outputted by B equals something. Now what we could do is we could say the voltage being outputted equals perhaps we could have V. So this now is a string because this is the text that's being put physically onto the Spice netlist, as we've kind of discussed. It's a little bit like the raw Spice. So we could say that it equals the img. So if we did that right now, all we're doing is we've created a voltage source that we're going to sweep, and then this B circuit component is saying, well, the B source's output is equal to the imaginary voltage. So we're using the imaginary voltage to output a thing. So let's actually do that. So we're no longer sweeping the inputs, we're now sweeping the I. And I believe this should work. So let's put this over here for now. And then give it a go. There we go. So nothing has changed because all we're doing is passing the same value to the input. So perhaps what we could then do is say, well, actually let's double it. So V imaginary equals 2 times that. And now if we open it, hold on. Okay, apologies for that. I know what's happening. I was actually I've actually been running the wrong file, so classic mistake. I was running tutorial 4.1. We're now working on tutorial 4.2, so part 2 of this 4th tutorial. So now if I run, we're running like that. What we find is it refreshes, and V imaginary is it's 1 to 1. So, but now I could say, well, let's say the input voltage is double the imaginary voltage. So now if we run it again, you can see that the voltages on the has doubled. So we're now sweeping 0 to 10 because we're doing 0 to 5 times 2, obviously. So we can see that, this is how a B source works. We can use this characteristic. But what we're going to do now is we're actually going to use a piecewise linear function, which allows us to input a custom series of values. So this series of values, we can write them in directly actually. So let's say PWL. So when the thing we're letting it equal is a piecewise linear function, and then the piecewise linear function is going to act upon the value of V imaginary. So it's using V imaginary, and what we want to say is well, when V imaginary equals 1, we want the value to be outputted to perhaps be 0. And then what we want to say is, well, when the value is 2, we want the value being outputted by this function to be 5. And then we say, well, when the value is 3, let the value outputted be minus 2. And then we say, 3 minus 2. And then finally, let's just do 4, and we'll set it back to, let's say, 10. And then we close it. So now, if I run this, what we need to do is change what we are doing. So hold on. So we're going from, so now we're sweeping across the possible values we've defined within the piecewise linear function. So we're going from 1, and we're going up to 4, and we're going in steps of 1. And what you can see is it's flicking all over the place. So we're no longer plotting this sort of continuous value, but what we are doing is we're getting the correct, when the input is minus, and we can see here when node 1 is 0, we get this value. When it's minus 2, we get this value, so we can see that it's working. Very, very much working, which is really good. So brilliant. So we've managed to now sort of have a custom input vector or custom input array. However, this is a bit this isn't great, really, is it? Because what we want to be able to do is parameterize this and just let it run. So let's actually try and generate this sequence. Let's try and generate the piecewise linear function sequence. So let's create a variable now called vsec, and then before this, let's now try and generate the function. So now if we have some generic array called perhaps data, so the data could be 0 volts. What did we have before? I don't know, 0, 1, 5, minus 2, minus 3, and then, I don't know, 2. Okay, so this is our data. Now we're going to create a string which contains this data. So what we can do is we can say, look, vsec equals pwl v image, and we're going to leave this open-ended because we're actually going to add things onto it. And then let's say let's just make a loop value called 1, and then we're going to say for val in data we're going to do and we need to be careful here because the final value needs to not have a comma after it. So what we need to do is we need to say if loop equals length of the data, what we want to do is say vsec is plus equals, because we're adding it, and then because we want to format this nicely, we're going to have a space. We're going to go %d, comma, and then we're going to go percent. Let's do 0.3. So this is the index integer we're using, a bit like we were before, and then this is the actual value. So that's 3 points, and then we're going to put the loop, so the index, and then the current value we're doing. And that's important because the last value we want to end with a bracket. And then what we say is else we want it to do it with a comma. So that should now work. So let's try and run that. And it didn't work. So let me just have a quick look. Okay, we spotted the issue. I wasn't iterating loop, so let's do loop iterates by 1. And now what we should find, because you can see quite clearly here, we're not iterating whatsoever. So now if we run it, yep, what we find is we have 0, 1, 5, minus 2. And then we have these 4 points. Why is it not going all the way? We need to... okay, yeah, of course. So, what I was just seeing is I was like, hold on a second, we're only doing the first 4 values in the input data vector. However, as we can see, our circuit is correct. We've got it all the way up to the 6th index of the full passed-in custom data array or vector, and that is because we're not actually sweeping. Our slice isn't sweeping the whole way. So we need this value. We need to start at 1, go up in ones, and we need to go to the length of the data. Here we go. So let's try once more. There we go. So we now have all of the data being plotted. So this is now fully parameterized. I could change this data vector to whatever I wanted it to be. I could pass it in from some other bits of code, I could change it, I could run it. Admittedly, this isn't very aesthetic right now because it's just a jaggedy line all over the place. However, this isn't really for these kinds of plots. It's much more so that we can kind of pass in custom pulses and then see what the output voltage would be for that pulse. So we can now have a pulse input using PySpice, which is quite interesting, quite useful. Not a pulse input, just a DC. We can do a DC slice on values, but this will sort of it's a useful feature which you may or may not want to use. So let me just, if I change this to plotting axis. So now we're doing random points of this diode array, and we're not getting this random zigzagging line. You can see that we are indeed getting this, once again, we're getting this diode trend, but we're not doing these points in order. So there you have it. We've covered how to do a basic DC sweep. We've now also covered how to do a custom input vector for your DC sweep using some kind of imaginary node, which is controlling a piecewise linear function on a B source. So we've covered quite a lot today. I hope that's been useful, and I'll see you in the next one.